on the Richter scale. Well, they're registered on the Richter scale, but they're not enough to you know, cause any type of catastrophic damage. Now, I ask you that. So, I lived in the state of Nevada for 9 years. I have experienced feeling the world move a little bit, which is sometimes uneasy. And I would say at about 35 minutes ago, I think a small earthquake just came through Colorado. And this is why. The building went boom, the whole building, and then there was a few sways. Now, you might have thought it was a door just slamming, but I think a small earthquake hit.
I didn't feel it.
Huh?
Didn't feel anything.
Well, again, it's small enough that I felt it. So keep an eye out if there was something on the news later today that says, hey, small earthquake hit Greenwood Village area. I felt it. And if you didn't feel it, it's because you're not used to it, because it's, come on. But it was just enough to where it registered to me that it was an earthquake. And then that the swaying of the building took place. Now, so if you didn't feel it, I apologize. Hopefully we don't feel anything stronger, because that would be bad. But I just thought I'd share that with y'all. I thought that was interesting. Your homework last time was page 51, 52. Is that what it was?
Yep.
So if you would, get this out, please. I'll come by and mark it off. A couple of you have been asking, hey, what can I do to improve my grade? And which is great. I appreciate you wanting to improve your grade. But the main way that your grade will improve is to continue to play school and make sure you're attempting all of your homework. And if you happen to log in and take a look at your grades on the computer or on your phones that you all have, if you happen to see if you happen to see zeros, go get them done and then submit them. And they're submitted for half, but that's better than none. So that would be a really good opportunity if you're noticing your grade is lower than you would expect. Please, please, please take a look at what the assignments are and make sure you're attempting them. And again, each and every night there is an assignment, and I'm not trying to take away your home life from you or anything like that. It's just, this is how math works. So that's basically it. And then if you've done all of that and made sure that your zeros are now at least a 2, and your grade still is not doing well, then come talk to me and we'll try and figure out some other ideas for you for math. So that's just a little bit of advice from my end. And again, I'm not trying to take away from your learning or your livelihood, but part of school is indeed homework. And, you know, that's what I've been doing for a long time. And I used to do homework when I was in high school. So, holy cow, I'm coming up with my 30-year high school reunion. Oh, my gosh. I tell you, so I did not go to my 10-year, but I went to my 20-year. And you know what I found out about my 20-year? You know, there's certain kids that you don't like in high school, right? You're like, that guy's a punk, or I don't like that girl, or whomever, right? And it's not because you're mean and malicious, you just don't care for that person. You know, after 20 years, there's still people that I went to high school with that I really don't care for. You know, like, oh, they're not that cool. And then there was people, I thought this was really sad. I think I might have been the only person that told the truth of what I did for my job. I told them that I was an ear, nose, throat specialist and dealt with nasal reconstructive surgery. I thought that was good. No, I'm just kidding. I told everyone I was a high school math and science teacher, which I am. If you like it, you're what? There were a lot of people going, yeah, I was a doctor. It's like, dude, it took you 6 years to graduate from high school. You're not a doctor. So, people that rented fancy cars. Oh, yeah, it's my car. Why does it say John's rental? Oh, someone might have put that on my car. So, it's kind of sad. People that, everyone wants to feel they belong, which is a huge thing in life. And the unfortunate thing is some people create a fictional world that they feel they need to make for others that will allow them to be accepted. And I thought that was sad. But I guess I will go to my 30th. Let's see. It's not too far away. But I bet you there's still going to be people there that are still renting cars, that just went over to the fancy store to get a fancy looking shirt. Poor people. I don't know. Just enjoy who you are. I guess my point. Let's talk about math. I'm sorry, I'm on a tangent. That's bad. That first page, how was that? Determine if you have a relation as a function. 1, 2, 3, 4. All of them are pretty easy, right? 5 and 6, it asks you to find the domain and range represented by the graph. Do you feel okay about that?
Can you go over?
Yeah, sure. So let me just go over number 5, and then I'm pretty sure you'd be able to figure out number 6. So I'm just going to figure out what my points are. So I have -3, 2 is 1 point. I have -1, 0 is another point. I have 0, 3 is another point. And again, the order of these is not important. 1, 2. And the last one, I guess, is 3, 0. Okay? So all I did is I look at my points, and I'm giving you what the ordered pairs are. And then if you're going to list the domain, all you're going to really do is just tell me what all your x values are. It's up to you if you want to repeat them or not, if any of them need to be repeated. But that's the domain. Again, does it look like I'm really worried about the order? No. And then the range, and if you're goofing up the order, which is fine, just realize your domain and range don't need to necessarily talk to each other. When you start listing things like this, when you start listing things, so if you notice, I listed my domain this way, my range this way. So then that doesn't mean that 3 goes with 2, 3 goes with 0. Okay, but you're listing what your domain and range are, and it's not important that you list the order of them. Yeah. You good? The reason you list your domain and range is, one, right now we're just looking at the domain, and we're trying to determine if this relation that we have listed here, and this is a relation of points, does it fall into the category of, is this a function, a special type of relation? Is it a function? And if we look, none of our x values, none of our domain repeats, so yes, this is a function. Okay, and again, when you list your domain, you're listing all your x components, and then your range is all your y components, and then you're not worried about the order you're putting things in. What you're mainly worried about is, did the domain repeat? And that's all you're really worried about at this point. Now, much further down the road, later math classes, we'll talk more about the range and where its importance on types of functions. But as of right now, we're not worried about that. And you don't need to think, going, oh, I want to know. There's special things in later math classes. So I think the front page you should be pretty good with. And am I correct to say that? Okay. And then you notice the second page, we didn't have any of those weird, is it increasing, decreasing, what's it doing type of problems, which is fine. You will probably see some of those tonight, but I actually plan on going over quite a bit of that today. But then let's take a look at 7, 8, and 9. Let's talk about those. Number 7, they gave us what the equation is. Number 8, they want us to make an equation. And number 9, they want to make this equation. Is any or all of those you need me to go over? It's okay if you go overall? Yeah. 8. Anyone want to see 7? 7 okay? You want to see 7?
Can you do all three?
Let's do them all. Let's do all 3. All right, so number 7. So I'm on the back side. So we have y equals 7x plus 30. Oops. You know, if I could write, I'd be a scholar. No, probably not. So they gave us this equation. Hey, how you doing?
Hello.
Thank you very much. Oh, she's not here today. I don't know if she went. She's hiding from us. Sorry about that. All right, so they gave us this equation that represents a monthly cost in dollars of a group of X members that are joining some sort of fitness club. Okay? Identify the independent and dependent variables. Okay, so independent and dependent, so those are kind of words that you might hear in science. So independent and dependent. Dependent variables are y values, independent are x values. That's where you need to look at that. This is where we don't really like using independent and dependent all that much. Want to know why? They're not alphabetical. Okay? So if we were to go and do this, identify the independent and dependent. Well, the independent is the x value. So let's see, is there anything else they tell us about this? Represents the monthly cost y in dollars of the group of X members. So this is our members. And this is, the amount of money that they happen to pay. Your group has enough money for up to 6 members to join the fitness club. Find the domain and range of the function. Oh, okay. So your group has enough money for 6 people to go. Okay. So part B, you are allowed to put 6 people in there. So 6 members is here. So 7 times 6 plus 35. Let's see, that's 42 plus 35, right? That's 77. So, if you did not, so the y is the amount of money, agreed?
Is that part B?
Yeah, that's part of part B,
Thank you.
okay? So I want you to think about this. X represents the numbers, and your particular company you work for says, hey, we now have enough money in our budget that 6 of you could go. The other 4,000 people that work here, tough. I'm just kidding. I don't know how many people work at this particular facility, but they have enough to put 6 members in. Okay, so just to say that I am putting members into this club, how much do you think it's going to cost me as a company? What do you think? If I put 0 people in, how much does it cost me as the company? No, it does. I need to keep my membership active at this place. So what is it going to cost me? Yeah, $35, right? So think about it. If I put 0 in here, I get 7 times 0. That's 0. That's easy. 0 added to 35 is $35. So you're like, well, how does that take place? Well, let's say Cherry Creek High School wants to provide opportunities for the teachers to have some sort of workout thing. And let's say over, I don't know, someplace around here, they say, hey, fitness club, we want our people to come over here. And so the fitness club might say, okay, well, it costs you $35, and that keeps your file active. Okay, so it's like a processing fee. But then, for every person you send over here, it'll cost an extra $7 on top of that for the most part. Okay? So your group has enough money to send 6 members to the fitness club. So what is my Y value going to be as a minimum? And we already answered it, saying 35. But what would it be having 6 members over there? 77. So the Y is our domain, or excuse me, our range. Okay? Our domain, we might have 0 people up to the total in the company, right? Toco, call it. So let's put that in terms we know. So domain, I think we could have 0 people that we send to go to this club, and we'll make a square bracket, up to the total in the company. It wouldn't be infinite, would it? Would a company have infinite employees? I mean, we have only 7 billion people on the planet, so it's not infinite. I mean, it's a big number, but it's not infinite. Yeah, it could be 7 billion, but I mean, that'd be a weird company if everyone worked for the same company. I don't know if I want to be a part of something that works for the same company. I kind of like that I have choices, but I don't know, maybe y'all want to work for the same exact company no matter what. I do have a rounded bracket on that, and I think you could argue it one of two ways. You could say, well, it's a square bracket because there's only a certain amount of people working. I'm thinking it's a big company, so you might be hiring and firing and having people leave every day. So I think that might be our domain. Our range, as far as this one goes, would go from $35 up to $77 as far as our reason went. And really with this problem, this is the total amount of people in this company, but we said that we're going to only allow 6 people in there. So I think we could argue this could be a 6. And again, we're just using some common sense. There's not like a whole lot of math that's going, hey, you got to be done this way. So we're just trying to make some argument. And that makes it tough sometimes when I'm trying to grade some of your problems because there is some thought you are doing as far as the problem. So I think our domain should be from 0 to 6, including 0 and 6. And our range should be 35 to 77 in this particular problem. And then that's about all we'd have to do with that problem. So there, I did a little bit more than what that problem needed, but I think it's okay. The Little Stage Concert Venue, oh, that should be cute. I hope they have puppets. Can hold up to 200 guests for each event. The amount of money that can be made is a function of the amount of tickets, T, that can be sold if tickets are $7 each. Okay, so problem number 8. Let's see, things that we know. You can take up to 200 people. So I guess you'd have 200 seats in your theater. And each ticket is going to cost $7. So let's see. Was there a minimum amount? Like this little puppet show theater or whatever it is? Could they say, hey, no one showed up? Yeah. Could a negative amount of people show up? No. And they could have, once they've sold 200 tickets, it'd be like the rest of the people, hey, sorry, there's another show in an hour or whatever. So, let's see. So the amount of money generated, we could have the function at x is equal to 7 times x. And we have to know that x has to be less than or equal to 200 people. Would that make sense? And then we could make the bottom end of our stuff being this. So now this right here is indicating kind of our domain. This is what it's pointing to. Because we could have no one show up. The show could be bad or could get bad snowy day and we couldn't drive there. And then we could have a Saturday that everyone wants to go to. Okay. What is the maximum revenue that can be made? Well, let's just use logic. We can only sell 200 tickets. If I plug 200 into here, looks like they're going to make $1,400 any given show. And then determine the domain and range. Okay, the domain is this. So our domain we could list like this. We could go square bracket 0 to 200 square bracket. Our range is going to be a result of the money. So if 0 people come, 0 times 7 is 0. So our range could go from a day of making nothing all the way up to $1,400. That's about all you need to do for problem number 8. And then number
domain is the inequality.
What's that?
Will the domain always be?
Well, yeah. I mean, we were making that. That's how we were able to look at this, saying we could go 0 people to 200, or any even amount of people, or any whole person. You're not going to sell 2.6 tickets. You're going to have some guy come in with missing a leg and a tooth, saying you're only a 0.6 guy. So you could point at him. All right. The Uber you ordered costs $2.50 surcharge plus $1.10 for each mile driven. Ooh, we are so with the times. So you contact this Uber, whether you use it or not. You contact it saying, Uber, come pick me up. Now I don't know how this Uber thing works. Sorry, I'm not that cool of a person. I'm not taking these at this point. I mean, I'm kind of a homebody. I'm sorry. I know you guys would like to know that I'm out, being a rock star or something, but it just doesn't happen that much. But this Uber, if I know this correctly, I know that there's a certain app you could have on your phone. You could push it. Now, I don't know if you have to type in the address or somehow your phone now broadcasts where you're at, and that an Uber would show up. I'm just assuming this is how it works, but I don't know for sure. Do you guys know how it works? Anyone take an Uber? Do you just push a button on your phone and it goes?
No, you have to
Turn in your location. Okay. I imagine it could get to a point though where you have GPS on your phone where if you push that, it could.
Pretty much what that is.
Okay, other than type in where you're at,
Well, because it's just like the GPS shows where the car's at.
Oh, okay, cool.
Checks the car and how close the car is.
Gotcha. So let's just pretend this is how it works. I don't know. I wish I was a more traveled person. Oh, really? So I think how this is presenting is I hit the button for Uber. If the Uber shows up to say, hey, I'm here to pick up Mr. Stirrup, and they say, Mr. Stirrup, he left with somebody else, then they're going to charge me $2.50. Okay, I don't know if that's really true. I'm just saying how this problem is being broadcast for us. So write an equation. This is the equation. So once we get it, let's say we are there, saying, hey, sweet, you're here. I need to drive to this address, and let's say it's 20 miles away. Then you're going to plug 20 in for the X, and then they're going to add $2.50 to that each time. So write an equation. How much will it cost to travel 5 miles? So if you travel 5 miles, that means you're plugging a 5 in here. So that's 5.50 plus 2.50 equals 0, dot. Carry the one, $8. $8 to go 5 miles. Is that good? I don't know. Again, I'm not that Uber guy. I'm sorry. And then it says, how far could you travel if you're going to spend $19? Okay, so if I wanted to go 5 miles and plug this in for X, where do you think I'm going to plug this 19 into my equation if we're going to spend $19? I'm going to plug it in for Y. So 19 equals 110 X plus 250. Let's see, we can solve for X. So I'm going to subtract 250 from both sides. So that becomes, is that 1650? Did I do that math right? If I didn't, please help me.
So you go 16.
And then divide each side by $1.10. And if you had a calculator, is it 16 as it come out?
Yes.
Cool. Okay, so I want to spend $19. If I only have $19 in my pocket, say, hey, Uber, how far are you driving? It'll take you 16 miles in any direction. Okay. And then what's the minimum amount of money you will spend? You'll spend a minimum of $2.50. If the Uber comes going, hey, sorry, waste your time, saying, hey, charge you $2.50 because you wasted my time. And then if you have 19 to spend, determine the domain and range of this function.
It tells you how much it will cost.
Oh, does it? Okay.
I think that's what debit card.
Oh, okay. And then you pay off your phone. Isn't there something on your phone you have, like, put money in a certain account? Oh, okay.
Yeah, it tells you how much it'll cost.
One of these days, I don't know. Again, I'm not that cool guy. I don't even care. For crying out loud, I don't even carry a cell phone, so I'll never have an Uber. Get in the car. Where do you want to go, mister? I don't know. All right. Let's not worry about the last part. Go ahead and pass those forward. I'll make sure your name's on those. If you're passing anything else forward, let's also make sure your names are on those, please. And I know you guys might find it strange that I don't carry a cell phone. I just don't. I don't know. I'm boring. Coming out to you as well is old homework, so make sure you write it through. There might be a no-namer. If that happens to be yours, put your name on it and bring it on forward for me, please. Right. So these are kind of notes slash worksheet, but I think this is good for all of our discussion. All right. Let's talk about this problem we have up on this front page. But let's not worry about what the problem is saying at this point. Let's see, a point here, a point here, a point here. Bounce. Okay. So, oops. Okay. So, a few things I'm going to just label on here. This is the point -3, 0. This is the point 0, 90. This up here would be the point about 2.5 in the x direction, comma. Let's just call it 150. I know it goes a smidge above it. And then this is the point 5, 0. Okay. So this is similar to what you have on the front page. Do you agree? So a few things about this graph. It's coming down this way, and it ends this way. So this is actually something that is either raised to the 3rd power, the 5th power, 7th power, 9th power, anything like that. That's what this graph would be. We have it bouncing off the x-axis at one point, and then we have it crossing the x-axis at another point. So it bounces here, and it goes through here. It does cross the y-axis, which is fine. We have a maximum point here. We have a minimum point. These are local max and mins, meaning because these arrows continue forever and ever and ever, there's some things. So let's talk about where this graph is increasing. Now, I don't want you to write anything yet. I just want to highlight where it's increasing, and I want you to, you know what? I don't like that my highlighter is making a straight line, so we're going to bust out the crayon today. And we'll do this golden color. If you have your 64-pack Crayolas, bust out. Okay, so that yellowish, orangish color is where this graph is increasing. But I want to talk to you about what it means when it's increasing. Have you all heard of the term slope?
Yeah.
Slope? Slope, like slope of a line. So things you might have learned back in middle school and prior is you could have a positive slope, you can have a negative slope, you can have a slope that's 0, that's a horizontal line, and you can have a slope that's undefined, which is a vertical line. And a vertical line is not a function. So what this means is where my graph is increasing means that if I were to take any 2 points, no matter how close they are to each other or how far apart they are from each other, if I wanted to create like a whole bunch of straight lines, so like this, if I had a straight line here and then here, so this is my straight line as my pen as it goes through. So that line, that little tiny, no matter how close those points are together, on that region, if I found the slope would be positive. Does that make sense how I said that? And you know how you had you could have 3/5 as a slope, and that's a positive slope. It means it goes up 3 and to the right 5. You could also have a negative slope, which means something different, but it means it's going to be negative. But if I were to pick any 2 points, no matter how close or far apart they are from each other as far as this region goes, we would be able to find the slope of the line being positive. And that's a big thing to know. So it says, where is it increasing? And I just want to put, it's increasing where our slope would be positive.
Yeah. Is this for yesterday?
Yeah.
Okay. Do you have this old?
Oh, wait. Let's see. Danny, oh, there we go. Danny didn't collect here. This row. Yeah, didn't hit this row yet. Let's pass this back. We should be able to that back. Okay, does that make sense if I just said that? It's increasing where if I were to pick any 2 points, if they're really close to each other or they're really far away from each other, they would be positive. And the slope equation is y2 minus y1 over x2 minus x1. You might have seen that. But let's just talk about this. So now, we're looking for the intervals. And for most part, you're always going to tell the story as the x component. So from here to here, between those 2 green circles, we have an increasing or a positive slope. Okay? So where does this start in the x direction for a positive slope? Yeah. -3. And you're only worried about the x, okay? And then where does it stop as far as that goes? Go ahead. 2.5. Now, I want you to all be clear of this. So it starts at -3 and it goes to 2.5. Okay? Now, the reason why I'm using rounded brackets, this is not a point, but the reason I'm using rounded brackets is because right here at this point, this line would have been a horizontal line. And a horizontal line, you might know, has a slope of 0. So what happens is, this would be a negative slope, coming down negative slope, and as it transitions from a negative slope to a positive slope, it's got to have at least one section of it that would be horizontal, and then now it goes positive. And then the same thing up here. It's positive, gets to this peak, which means it would be a horizontal line through that, which means it has a slope of 0, and then it starts with a negative slope as it comes down. Okay? Does that make sense how I just said that? I mean, that's a big thing to see. This graph between here and here would have a positive slope. That means it's increasing. That's like the fundamental part of starting calculus. And I know we're not starting calculus, but that's the fundamental part of it. Okay? Now, if it's increasing there, that means if it's coming downward, it's decreasing. So this whole region here is decreasing, and this whole region is decreasing. Okay? And again, we need to look at the where it's coming from. Decrease, that's an S, S-I-N-G. Decreasing, just spell it right. I did spell it. So this here, all of here is decreasing, and all of here is decreasing. Okay? So, again, we're going to use the x component to tell it where it's decreasing. Where is this going this way? Negative infinity. So it's decreasing from negative infinity all the way up to what point? No. It's decreasing all the way up to what point? -3. Okay, so it's decreasing from negative infinity to -3. And again, it's a rounded bracket at -3 because right here, as it would transition from a negative slope to get to a positive slope, there would be one instant that it would be a slope of 0. And that's a big idea, okay? And then, in between here, this gold region, we found that it was a positive slope, so it was increasing. And we get to this point, which is 0, and now we're going to start decreasing. So using the x component, where did it start decreasing again? 2.5. And where is it going to? It's going to positive infinity. That's it. Okay, it didn't end. It kept going. The arrows at the end means it keeps going. So increasing means you would add a positive slope. If you picked any 2 points, you'd have a positive slope. You found it. Decreasing means you would have had a negative slope. If I picked any 2 points along here, my slope would be negative. Or any 2 points along here, my slope would be negative. And that's what increasing and decreasing means. Does that idea make sense? And I can't, and I'm always refer back to it, as talking about the slope. And I realize we're not talking about a straight line. It's just as if I were to create a straight line and pick 2 points, my slope would be positive here. If I pick 2 points and I wanted to make a straight line out of this, my slope would be negatives. Okay? Then they ask for, let's see if we can figure all these out. Down a page. So they want us to find function at 2, function at 0, and then the function at -3. Okay? So if you look on your graph, find your 2. Okay? My graph doesn't have everything there, but I have 1, 2, 3, 4, and 5. So I found my 2. Okay? So what does it appear about the y component would be at that point? 2, 150? Okay. So you just went up to the y part of that. Oops, come on. Okay. And the function at 0, this is 0 right here. What does the function at 0 seem to yield us as a point, as a y component? 90, yeah. And then the function at -3, what is that y component right there? 0. And again, remember yesterday I told you all about, hey, this creates these points if you wanted to make them points. Okay? Okay, now let's talk about the domain. Our graph, when you look at your graph on your paper, does your graph go forever to the left and forever to the right? So the domain is going to go from negative to positive infinity. Okay? And then the range, this is where people start stumbling a little bit. Okay? We do have a minimum and a maximum, but our graph continues this way. And our graph continues this way. So my range is like an elevator that I would take up and down. If I were to take this elevator straight down and we're able to look out either way, if this graph continues this way, will I continue to see the graph as I continue to go down? I would. I'd be able to see it out here. Now, if I took my elevator up, we would see different parts of it. But let's say I get way above the graph, and I'm way up here, and if this is continuing to grow, can I still see my graph as I go up? Does that make sense how I'm saying that? What do you think? Can I see the graph as I keep going up? I saw it as I kept going down. Can I see it as it keeps going up? The answer is yes. So my range, come on. My range also goes from negative infinity to positive infinity because of how the graph is set up. The intervals for which the function is positive. Oh my. Okay, so this is now a different thought. We want to know where our graph is positive. Where is it positive? This means where is our graph above the x-axis? Okay? So this is a little different idea. This has nothing to do with that it is increasing or decreasing. This just says, where is our graph above the x-axis? Okay? So where does our graph appear to be above the x-axis? Is it above the x-axis here? Well, I guess maybe we should label what's the x-axis. Is this the x-axis or is this the x-axis? Horizontal x or is vertical the x?
Horizontal.
So horizontal. So where is this graph above the x-axis? I'd say over here it is. Right here it kisses it once. If it kisses it, it's not above it. And then from all the way over to here, this is all above. And then right here where it crosses, it's no longer above the x-axis. Do you agree with that representation? All right, so it is positive, and we're going to talk using the x, going from negative infinity all the way up to -3. That's positive. And then from -3 all the way to 5. And they're all rounded brackets because if I get to the number 5, I'm at 0, and that's not positive. And if I get to the number -3, that's also at 0 because it's kissing off the graph, which means that's the point -3, 0. Okay? And that's the long and the short of how you would go through this type of problem. Is that okay so far? I think you would be able to do the same thing on that backside sheet. So what I want you to do tonight is think about that back sheet, back 2 sheets. Think about it. No. I just want you to think about it, okay? The very furthest back sheet, I think, is pretty doggone easy. We'll run through that real quick. I'm not going to check that off as homework. I just want you to think about what those sheets would be doing as far as the information you just learned, okay? And so, why don't you take a look at pages 53 and 54. Page 53 and 54 is the homework. I will warn you that problems 1 through 4, you might have questions on. So try it, and if we need to, we can go over it. But do all of page 53 and 54. You might come across questions on 1 through 4. And really what it is, you have from number 1, it says function at x equals 6x, function at x equals -24. So you're going 6x equals -24. Number 2 says g of x is equal to -10x, and g of x is equal to 15. So you're saying that -10x is equal to 15. You're solving for x. That's all you're doing. You're setting them equal to each other. And then that's about all we have. I think you have enough information to do a really good job on pages 53 and 54. Sound good?
Yeah.
Happy?
Yeah.
No?
Thank you.
We're out of here at 10:06, right?
Yeah.
Okay.